This session is about the central limit theorem. The talk outline has a population explanation, sample, central limit theorem, and the central limit theorem example. What is a population? It is a complete set of numerical information on a particular quantity in which we as an analyst are interested. Example, suppose we would like to find the average height of all males in India, then the population would represent all males residing in India. Suppose we would like to understand the percentage of votes that a certain candidate would get from an election within a certain constituency. For this population would represent all voters of the constituency. What is a sample? It is a subset of the relevant population that is used to make inferences about the population. The sample must be representative of the solution. Example, we would like to understand the average height of all males in India, then the sample would represent some males residing in India. And the sampling should be done such a way that we do not restrict ourselves to a single region but to multiple regions in India because the height may vary from region to region. Similarly, we would like to understand the percentage of votes that a certain candidate would get for an election within a certain constituency. The sample would represent some voters of the constituency, but to remember that we have to get the sample such that it is representative of it, because some regions in a constituency may vote for a certain candidate, other regions may not vote. So it is very important that the sample is collected properly. Now comes the central limit theorem. Consider a random sample of n observations from a population with a mean mu and a standard deviation sigma. So this is the population distribution, and now we take sample sizes of size n, and each sample size may have a sample mean. So these are the sample means, and then the distribution of x bar, that is the sample mean, is approximately normal with a mean mu and a standard deviation of sigma by root n, where n is the number of samples collected. So this is a great theorem, and we will apply it very extensively in different cases. Note here that the population distribution may not be a normal distribution, but the sampling distribution of the mean is a normal distribution. So that's a great thing, meaning very interesting thing. So let's consider an example. Population all computer science students who finished their engineering last year in Karnataka. The mean salary is mu and the standard deviation is sigma. The sample is the sample of all computer students who finished their engineering last year in Karnataka, and the mean salary is x bar and the standard deviation is s. Now let's consider this example. So all engineering students, the mean salary is 500,000 and the standard deviation is INR 20,000. We survey a sample of 50 students and below is their salary. Mean salary for 90,000, 100,000, 10,000 is the standard deviation. Sample 2, 510,000, 18,000 is the standard deviation. 480,000, 15,000, 520,000, 20,000. But the sample salary will follow a normal distribution with a mean of 500,000, which is equal to the mean salary and a standard deviation of sigma by root n, where sigma is 20,000 divided by root n, where n is 50. So 20,000 by root 50, since the number of students in each sample is 50. So this completes a very short introduction to central limit theorem, and we will go in depth and understand of how we apply the central limit theorem in the subsequent lectures. Thank you. Bye.